Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 431. I was able to solve first three problems. First I got two penalties, one in second, and third I solved without penalty. My rank is 537 and I finished three problems at 8:55 a.m. and based on this I have pretty bad rank, I would say. I tried fourth one for some time, but I was unable to get a small start or even small observation. I couldn't get, so I gave up on fourth problem. So now let's start with first problem. As usual, this is a brute force problem. So we are given an array of positive integer nums and we have to find a subarray such that it is product equivalent. Now what product equivalent means? That product of array is equal to LCM of that subarray into GCD of that subarray. So product of array is product, GCD is GCD of whole array, and LCM is LCM of all the elements in that array. Now we have to return the longest product equivalent subarray in the given array nums. So for example, in this array nums, the longest subarray can be 1 2 1 1 1. So last five elements. So the product of that is 2, GCD is 1, and LCM is 2. So GCD into LCM 1 into 2 is 2, which is equal to product. That's why here answer is 5. Similarly, here answer is 3, here answer is 5. You can go through the possible solutions. But yeah, this is basically a brute force solution. So we just have to write brute force solution. Main concepts are how you find GCD and LCM. So first of all, ignore this limit and just focus on the brute force. So we are starting from 0 and ending till iterating over all the indices till n. Then we are initializing three variables: product, product, GCD, and LCM. Now, if this is equal, the condition is matched, then we just make answer equal to 1 because the element I itself can also form a subarray. So yeah, and we just consider one can be 1 as our answer. Then I'm iterating from I plus 1 to n. So all the subarrays which are starting from I and ending at any index after I. Then also ignore this condition for now. Then we take product of product multiply a of j to our product variable. Take GCD of g and a of j and take LCM. Now this GCD is inbuilt function, but LCM is this function which I have created, which was in my template. I just copy pasted here. And formula for LCM is a into b. So let's say we have to find LCM of a comma b. It would be equal to a into b divided by GCD of a comma b. So this is the formula for LCM. You should try to remember this, and also you can take a look at the proof of this. So basically I found all three variables for that subarray, and then I'm just checking if product is equal to GCD into LCM or not. If it is equal, if this condition is satisfying, I'm just taking answer with max of j minus I plus 1, which would be the length of that subarray. Now if we this condition of limit, I added this because the product here, max product, would be 10 into 10, which will go up till 100 times, because 10 is the maximum array element and 100 is the size of array. Now here the product would be 10 raised to the power 100. Now we cannot store that value in integer data type, which is even long cannot store it, because long has limit of 10 raised to the power 18. So the issue here is when it goes integer overflow. When it goes above 10 raised to the power 18, it will give you error. This Leetcode compiler gives you error, but usually it will go into the value might go into negatives, and eventually your output would be wrong. But what this limit does, now let's say product is 1E12. Let's consider this product as 1E12. Now GCD of all the elements would be uh, GCD of all the elements would be max 10, right? So this is production by product. Let's say this is GCD and max value would be 10, because let's say all the elements in the array are 10. Somehow we are getting GCD as 10. Now similarly, what is the maximum value of LCM? Now LCM here would be, so let's say we have A and B. Now to get LCM of these two elements maximum LCM would be A into B, because they won't have a common multiple up to A into B itself. So example of this can be, let's say 2 and 7. 2 and 7 have LCM as 14, because there is no other element before 14 which is common multiple of both of them. So maximum value of LCM of two elements can be A into B. Similarly, in this case, what would be the maximum LCM? It would be 10 into 9 into 8 up to 1, because even if we repeat multiple elements in the array, their LCM would eventually come out to be 9. Now, so we only have 10 unique elements whose LCM can be 10 into 9 into 8, which is equal to 10 factorial. Now 10 factorial, let's just assume it as 10 raised to the 10. It is lower than this, but we can just make it off, we can consider it as and offset up to 10 raised to the 10 into this 10, which is 10 raised to the 11. So LCM and GCD is 10 raised to the 11. This is also not a possible case, but just consider it. So maximum product of GCD and LCM is 10 raised to the 11. Above this it cannot go. So what's the point of iterating over subarrays whose product itself is going above 1E12? So that's why that condition is added. So if we add that condition, we also don't need to worry about integer overflow. So after 10 to the 12, we just break the second for loop. We won't go into further multiplication. So 10 to the 12 into 10 to the into 10, 10 to the 13. So it will never go above 10 to the 12. So that was the mistake which I did first. I didn't add this uh, condition, and that's why I got two penalties. And I'm not sure in Python there is what is the limit for storing integers, but I think that could have been in Python. There would be no requirement of this condition. I'm not sure, but probably. Yeah. So this was first question. Now moving to second one. So in second question, we are given a string S. We define the mirror of a letter in the English alphabet as its corresponding letter when alphabet is reversed. So for A it would be Z, for Y it would be B. So Y is second character from end. Find first second character from start. It would be B. So this is the definition of mirror, and we are given a string S where all characters, all indices, and all characters on that indices are unmarked. And we start with a score 0, and we have to basically iterate from left to right. Now, we are at index I, we have to find a closest unmarked index j such that j is less than I, and s of j is mirror of s of I. Then what we have to do is mark I and j, add I minus j to our total score. And if no such j exists, we just move on to next index without marking it. So if we found j, then only we mark both the indices. If we do not find it, we just move forward. So this is a sample case ACZZX. Now for I equal to 0, there is no j before 0, which has, so for A's mirror would be Z. So before A there should be a Z which should be unmarked to mark this A. Now for 0 and 1 first index, again for C it would be X, and there is no X previous, so we skip them. For I equal to 2, which is Z, there is its mirror character A at index 2, at index 0. So we add 2 minus 0 to our score, so our score becomes 2. For I equal to 3, we skip it. Now we won't consider this A again because it is marked now. We need to find unmarked index J, and that to closest. And for index 4, we its mirror character is C. We found C at 1, so 4 minus, we add 4 minus 1 into our score. So let's just take an example. So first of all, for A, is there any previous character? No. For B is also no there because C is no. For Z, there is this A, which is its mirror and which is previous to that index, and uh, it is unmarked. So here, what we'll do is we will mark this, this will remain unmarked, and our score would here would be 2. Now for X, uh, there is this character C, which is its mirror. So X is third character from end, third character from start would be C. So we mark it, and X, the index here is 4, here is 2, so we add again 2. Now for Y, we have B, so we mark B also and add, uh, so this is 5, this is 1, so I add 4. So, and for D, there is nothing, so there is no W before it. So D is fourth character, from start we find fourth character from end, which is W, so it is not there, so it will be unmarked. Now for W we have D, which is its mirror, so we mark it. This should remain same, and we need to add 1 here, so our total score will become 9. Now what information is required here? So let's write those informations. 1, index, closest index of characters. Second is we just need a score variable, and also if index is marked or not. So for W, let's say I am iterating over a character which is W. We will first find its mirror, which is D. Now after finding D, what we'll do is we will check if there is any index before D, for D before the index of W, which is unmarked. Now the solution for this is to maintain a character to stack mapping. So for each character in A to Z, what we will do is we will maintain a stack. Let me So we will maintain a stack, and the stack top will be the closest index, or the most recent index at which we found it. So let me just show you. Take, let me just take one example. This Now we have A, B, Z, X, and we need anything Y also for X. Yeah. So first we are at 1. We are at index 0. Age mirror character is Z. Now at start, Z's stack would be empty. So this is just horizontal representation of stack. Don't confuse it with Q. So what we need is Z's previous index, because Z doesn't have any element before it. The score would remain still 0. But now we'll push A's character, A's index in our stack of A. So we pushed 0 to stack A. Now for C, its mirror character is X. X stack is also empty, so there is no matching. Score still remains 0, but we push uh, we push 0 to our to the stack of C. Sorry, not 0, 1, which is index of C. Now we move to Z. Now Z's mirror character is A. Now we have its stack top of A has an index which is 0. So we can match these two. So here score will become 2. So 2 minus 0, and we will pop this 0. What popping that element in the stack means? We are basically marking that index. Now Z is also marked, so we will not push Z into the stack. But score here would become 2, and we move to next element. Now Z again, its mirror element is A, but the stack is empty because we just popped it one index which was present there, and now stack for A is empty. So again score remains 0, but this time we push index of Z into our stack, so 3. Now for X, its mirror element is C, so we find C's stack, and it would have an element there which is 1. So 4 minus 1, we add it, so our score becomes 5, and then we just pop that element as we have marked it. Now moving forward, we will not push the index of X because it is also marked. Now why I'm using stack? Because let's say there were two elements at index 3 and 5. Now while pushing this, when I move to 7th index, my stack should look like this: 5 3. Means I basically need to find closest element, which is 5 years. So closest from 7 is 5. So using stack, what I'm doing is I'm pushing first 3, then when stack is just last in first out. So 5 was pushed last, and I want the closest one. So I will pick out the stack's top element which is pushed very recently. That's why stack is used. So this is the solution for second one. I hope you understand this simulation. Now I'll move to code. So first of all, I have declared a integer to stack mapping. I'm not working with character here. I'm just used integer. Then I have declared an answer variable to store score. First of all, I'm finding its index in alphabetical order. So S of I minus A. So if it is A, it will give me 0. If it is B, it will give me 1. If it is Z, it will give me 25. Now to find its mirror, I'm just taking 25 minus IDX and storing it in IDX itself. Now if there is no mapping initialized for that character, or if its stack size is 0, I will just push it and move forward. Else I will add current index minus its top index into my answer or score and pop that element. So this is um, popping that element is, it is marked and it is not useful for further. So removing it, and finally just returning that answer. So this was the second question. To be honest, this is more easier than first. I struggled in first, but this clicked very fast, I would say. First one has some difficult implementation. This was very easy. Yeah, let's move to third question. Now, third question is interesting, I would say. 553 rankings. So let's just start with third question. In third question, what we are given is we are given a 2D array coins, and coins of I represents that all the bags from L to R contains Ci coins. So there is an infinite amount of bags on a number line, and we are given a, a range L to R, a array of ranges, and each range L to R there are C coins. Now this information is represented by this array coins, and there is this also additional information given that none of the segments are overlapping. That means only single index element is representing the coins. That means basically no two ranges overlap, no two ranges have intersection. And we are also given an integer k. So we basically need to find maximum amount of coins you can obtain by collecting k consecutive bags. So let's just take one first example. 8, 10, 1, then 1, 3, 2. So let's just draw this number line first. And now we'll put the number of coins here. So 0, 0, 5, 6, 4, 4. So this is the input which we are given, and this is how it looks. So 1 and 2 back. So this also we should be. So 1, 2, 3 bags have 2 coins. 5, 6 have 4 coins. Let me just confirm 5, 6 here. And 8, 10 have 1 coin in each bag. So now we are also given k, which is equal to 4. So we need to find maximum sum of coins in any 4 consecutive bags. Now for 4 consecutive bags, what the options are: 1 to 4, 2 to 5, 3 to 6, 5 to 7, 5 to 8, 6 to 9, and 7 to 10. So 1 to 4 has 6, 2 to 5 has 8, 3 to 6 is 10, and I think 3 to 6 itself is maximum. You can calculate for all other and check. So this segment gives maximum answer, which is 10, and we just need to print that maximum answer. Now looking at this type of configuration, you would think this is a sliding window type of solution, but the problem here is with the constraints. So k here is up till 1e9. Similarly, L, R are also uh, till 1e9. So we cannot use a sliding window and prefix type of solution. So what could be some observations which will be used to solve this problem? Now, first observation or assumption which I did was the subarray which will give not subarray, the segment which will give max answer. Let's consider its segment can be x plus x to x plus k minus 1. So k consecutive backs. Let's consider this is the segment which is giving us maximum number of points. Now this segments which I assumed was that starting element or its last element is so not starting and ending. So what I assumed was this starting element is either equal to starts of all the segments, starts of all the intervals. So 8 to 10, 1 to 3, 5 to 6. So this x is either one of the starting integers of intervals, or it is one of the ends. So in our first sample case, the x would be between 1, so let's just start 158 and 158 and 3610. This x would belong to these any of this only. So I assume this. So 158 is all the starts of all the intervals. 3610 is all the ends of all the intervals. Now why I'm saying it like that is because let's say this is my max. Assume this is my max. It would have some kind of configuration like this 6 3. Now why is that? Because if this is giving me max, why would I move forward and subtract 6 and add 3? So this will decrease my score. So instead of this, I can take this score itself. Now also other so this is not like this. X belongs to this starts, or x plus k minus 1 belongs to these three elements. So start either belongs to uh, all the start indices, or its end belongs to all the ends of intervals. So these two conditions, we just need to check maximum score for these two configurations. So this is the explanation or kind of intuitive proof for this. So if we start from x, which has a 6 number of coins, and end which has 3 number of coins, moving forward would decrease my score by -6 but increase by 3. Now if this was greater, let's say this was 6 and this was 7. Now I will obviously move forward, so adding a score of 7 and decreasing a score of 7 and decreasing a score of -6. But I will keep moving forward up till that end is an intervals end. So based on this, there is this second condition where x plus k minus 1, or the end of a segment, is end of an interval, and start of our segment is a start of an interval. So eventually what we need to find is, we first need to find, iterate over all the start integers of our intervals and find score for that, and we need to iterate over all the ends interval and find score for that. So this is where it starts and this is where it ends. So in our case, the starting intervals were 1, 5, 8. So starting intervals were 1, 5, 8, and ending intervals were 3, 6, 10. So what we need to find is answers for subsegment 1 to 5, 5 to, no, not 1 to 5, 1 to 4, 5 to 8, 8 to 11. So starting all the indexes up to 1 plus k minus 1. And other part is if the segment ends with one of the ending interval. So 3, 6, and 10. Now 3 start would be 0, 0 to 3. This would be 3 and this would be 7. So we basically need to check all these subsegments. Now, so this subsegments would be around 2 into n. N is the size of uh, the coins array. Now, how can we do that? So let's say we consider an start index as x. We fix it and we have to find the answer for x comma x plus k minus 1. I think there are multiple ways to do it, but what I did was, first of all, for each element from 0 to n minus 1, I've calculated its contribution in the score. So 1 comma 1 comma 3 comma 2 is one of the intervals. So 1, 2, 3, and each bag has 2. So its whole contribution would be 6. Similarly, 5 to 6 and 4 would be uh, so 5 to 6 and 4 elements. So 2 into 2 elements, each having 4 number of coins. So contribution of that interval would be 8. So I sorted the intervals based on its end. Then I find each interval's uh, contribution and then take its prefix sum. So 1 3 interval has 6 contribution, 5 6 interval has 8 contribution, and 8 10 contribution had 3 contribution. Then I take its prefix sum 6 14 17. Now for first segment, let's start with first. One adds its segment start, its end would be 4. Then what I will do is I will find fourth upper bound end. So what, for element 4, its next interval which has end greater than 4, which would be 6. So for 4, what I'm doing is I'm finding this interval. So I got its index as 1. Now from 1 to 4, we can say its contribution as 1 to 3 plus 4 to 4. Now 1 to 3 can easily be calculated by the prefix sum which we are using. So 1 to 3 we will just take its prefix. Now not exactly its prefix. What we will do is we will take prefix of first, which is this prefix. So 14. So this is the contribution of 1 comma 3 plus 5 comma 6. This is the whole contribution is 5 comma 6. Now what we want is 1 comma 3 plus 4 comma 4. Now how can we remove this and get this? So we basically need to remove contribution of the interval 4 to 6. So to remove contribution of 4 to 6, we need to again separate this subsegment. 4 to 4 is 0, 5 to 6 is 8. So we get 8 and we have to subtract it from our original answer, 14 minus 8. So answer for this segment is 6. This is kind of difficult to understand here, but I think code wise it would be better to understand. So what we are basically doing is for each in starting elements of intervals and taking ends of segment as all the ending elements of intervals. So we are checking its all the scores and taking max of it based on these observations. So I will explain the code. I think that would be better. First of all, I'm sorting the C. Then what I'm doing is I'm basically storing a prefix and a ends vector. Now what prefix will store? It will store contributions of all the intervals till I. Now what is the contribution of each interval? So r minus l plus 1. So number of elements in that interval into the number of coins each bag has. And I'm pushing ends into a ends vector. Then I have declared a result variable. Now there are two conditions. One is for if this current interval start element is a maximum segments start element, which is let's say c of I comma 0, I of 0, and its end would be starting element plus k minus 1. Now I am finding the index of the intervals ends. So for 4 it would be next end, which is 6. Similarly, let's say if we have to find end for 8, next end, which it would be 10. For 1 it would be 3, for 3 it would be 3 itself, for 4 it would be 6, for 5 it would be 6, for 6 it would be 6, but for 7 it would be 10. So next element, which is also an end of an interval. So that we can do using upper bound on the ends vector. Then I have declared an answer variable to store temporary score. So first of all, we take its prefix. There is this condition to avoid segmentation fault. Then to remove that contribution of that segment, additional segment. So this 5 6. There is this, and finally for all the elements before this, for all the intervals before I'm just subtracting their prefix sum and taking its max as answer. Now this is the code for when the interval start is a starting element of max segment. Now there is also we need to check when that intervals ending is also an ending of max segment. So here start would be c of I comma 1. Here start is the rightmost end of segment. So I'm uh, referencing that segment in reverse order. Then end would be starting element minus k plus 1. Now what I want to do is I want to find ends uh, element which is greater than en but is also a interval ending point of any of the intervals given in the input. So for that I'm taking its lower bound. Then I'm first of all storing its prefix sum, then subtracting that idx prefix sum. So I will have all the contributions from idx plus 1 to I. Now there would be some contribution from this ending element. Then I'm re-adding it. So while subtracting this, the ending element would be in between that interval which is pointed by index idx. So to re-add that its contribution, I am doing this and taking answer as max of result. This is a difficult question, I would say. At least to explain, I found this difficult. But yeah, I think go through this code probably. You might get an idea of what I'm doing. And talking about this fourth problem, I don't have a slight idea of what I need to do here is. I just know probably brute force. So I will try to solve this after some time. And rank 553, it's kind of bad, I would say. Let me just check what would be my rank if I haven't made this sub penalties. Not a lot of change, I would say. My rank would be 450 if there were no two this there would if there was no penalties. But yeah, if you don't know about this predictor, there is this website called as lccn.ilbao.site. Here, after every 15 to 20 minutes of contest, you will get a prediction, and this is pretty accurate, probably 100% accurate. So my current rating is 2324. So this is in decimals, and my predicted rating is 2332. So you can also check this out if you want. This provides some pretty good statistics over every 2-minute interval, how many questions were solved. There was sudden spike in solves, etc. Check this out if you are not aware of this. But yeah, it was interesting contest. Yeah, that's it. I will try to upload all the editorials from now as possible. And thank you for watching.